So I don't have anything witty to say today. I'm going to get right down to it. The title of the notes is called Neutralization Reactions. And basically, just kind of giving you a backtrack, H plus, remember, that typically means it's an acid. And if we see something like OH minus, that means it's a base. Or we need to think base. So hydrogen acid, hydroxide, OH minus, that is a base. Now a neutralization reaction, now let's go ahead and define it. A neutralization reaction is when a strong acid and a strong base react together to produce a salt and water, H2O. So some examples of this are, let's say I have HCl, which is hydrochloric acid, and I add it to sodium hydroxide, NaOH, which is a base. I would get water, H-OH, and a salt, NaCl. So notice hydrogen is +1, chlorine's -1, sodium is +1, and hydroxide is -1. Notice that the positive on one, hydrogen, meets up with the negative on the other, hydroxide. So hydrogen and hydroxide come together to make water. And notice chlorine and sodium come together to make NaCl. So this would be a double replacement reaction. Notice how they're switching partners. H and OH come together, and Na and Cl come together. So I have my acid, and I have my base, and when they react together, they make water and a salt, sodium chloride. Noticing some more, notice you have one hydrogen here, and there is one hydroxide here. Okay, and they kind of cancel each other out. The acid part, there's one sort of acid part, and there's one base part, and they just completely cancel each other out. And I end up getting something that is neutral. And once again, neutral, that means not an acid or base. The pH should be 7. Okay, let's do a couple more of these problems. So let's say I have H2SO4 plus KOH. That gives me not H2. That gives me K2SO4 plus H-OH, or just water, okay, because HOH is water. Balancing this guy out, you have a 2 in front of KOH and a 2 in front of water. Now, notice, once again, there are 2 H's here. Okay, and because I put the 2 in front to balance it out, there are 2 OH's. Okay, they cancel each other out. So I'm going to go ahead and switch colors. The H and OH are equal. They cancel each other out, comma, making a neutral solution. So I started with a hydrogen, started with 2 hydrogens, 2 sort of acid things, and I started with some hydroxide, some basic things, and I made a salt. Technically this is a salt because it is a metal and a non-metal, sort of. That's kind of one of the definitions. Also that it's an alkali metal, the K2, and I get water. So just noticing that the hydrogens and hydroxides cancel out. That is what a neutralization reaction is. When your H's and your OH's, when they are equal and they cancel each other out. Let's see, where am I on time? Okay, let's do one more example of this. Let's do KOH plus HNO3. That gives me H-OH water and KNO3. And it's nice and balanced. Just noticing once again, there's one OH and there's one H. They cancel out. Okay, so there is an equation that we are going to be working with, and I'm going to sort of give us our what do I want to say? The question. So I'm going to say find the volume needed to neutralize. Now this equation is going to be number of H's times MA VA equals number of OH's times MB VB. This is the same exact thing as M1 V1 equals M2 V2. Same exact thing, people, except just a little bit more difficult. We're just adding hydrogen and hydroxide. So I'm going to box this guy because he is our equation, and I'm going to label all of my things. So number of H's, that's just number of hydrogens. Ma is the molarity of the acid, and Va is the molarity of the base. I think number of OHs is self-explanatory. Mb is the, oh no, give me a point. That is the molarity of the acid. Jumping ahead of myself. So the A's stand for acids. Molarity of the acid. That is, wow, give me another point. Give you guys another point. That is the volume of the acid. I apologize, guys. So Ma is molarity of acid. Va is the volume of the acid. Mb is the molarity of the base. And Vb is the volume of the base. Okay, this is the same exact formula as M1V1 equals M2V2. Just we're going to be adding hydrogens and hydroxides. Now, I've run out of room, so I'm going to flip the page. You don't have to. We're going to do our one and only example. Trying to make this under 10 minutes. Hope I can. How many milliliters of 1.75 molar NaOH will neutralize 35.5 milliliters of 7.5 molar sulfuric acid. So I'm going to write my information down the side. I need number of H's, MAVA. Okay, separate that, and I need number of OH's, and I need my MB and my VB. So I've got my formula. It is number of H's times MAVA equals number of OHs times MB VB. So let's go ahead and figure this out. So it says, how many milliliters of this molar sodium hydroxide? Now, this guy, this is my base. Okay, and they said how many milliliters of the base. So they want the volume of the base. And it told me my molarity of my base. I know it's a base because it has the hydroxide there. So the molarity of my base is 1.75 molar. And my formula for my base is NaOH. And there is just one hydroxide there. It's just NaOH. So there's just one hydroxide. We'll neutralize this many milliliters of this molarity acid. So this is my volume of my acid right here. So that's my VA, 35.5 milliliters. Molarity of my acid, so this is 7.5 molar. And the number of H's. Well, I know this is my acid, but I can't see the formula. So I have to find the formula. So sulfuric acid, 8 ic. Sulfuric acid comes from 8, so it comes from sulfate. Sulfate is SO4 minus 2. So you plug an H plus 1 in front because it's an acid, and your formula of sulfuric acid is H2SO4. Now I can see that there are two H's. There are two, quote, acidic hydrogens in this. So that means my number of H's is going to be 2. So now that I have my number of H's, I have the molarity of my acid, I have the volume of my acid, I have the number of hydroxides, I have the molarity of my base, and they want the volume of my base. I'm just going to plug and chug. So there are 2 hydrogens. Molarity of my acid is 7.5. Volume of my acid is 35.5. Number of OHs is 1. The molarity of my base is 1.75. And the volume of my base is, I don't know. Going to circle volume of my base because that's what I'm trying to find. So I divide each side by 1 and 1.75. Divide each side by 1 and 1.75. I type that into my calculator and I get VB equals, it spits out 304.285. We're giving everything in the chapter 3 sig figs just to make it easy. So VB equals 304. Now the volume of my acid was in milliliters, and so therefore the volume of my base is in milliliters, and that is what they asked for. And that is it. Okay? We're going to do a lot more with this later on, but for now, that's just what we're going to do, and hopefully it's under 10 minutes. Aw, man, I'm 13 minutes, 27 seconds. Sorry, people. Garvin out.